Welcome to the webinar Parametric BIM Design using Visual Programming. My name is Jung-Hoo Park from South Korea, currently working at Group Ventures as a BIM specialist. And also I'm on my own practice, Point One Studio. We are the design practice working with different architectural and graphic design project. If you're looking at the data exchange from design discipline to planning discipline, main tool for architectural design, many designers using Rhino 3D, and also 3ds Max or Maya. The thing is that this design tool has a certain degree of freedom to scheme their particularly geometrical um, properties rather than building information authoring software such as Autodesk Revit, Graphisoft, ArchiCAD, and there are many other BIM applications available. But the main problem I have observed between design department and BIM or planning department is that the language, how they use in terms of communication wise, there is always disconnection or duplicated work that BIM or planning department, when they take over design documentation, they pretty much have to reproduce or rebuild geometry in BIM authoring software that cost a lot of hours, as well as some case when project becomes complex and the geometry, if geometry is really complex, then the building information modeling planning department usually rationalize or sometimes ask the design team to compromise their design geometry. And this is somehow I found that not good practice. And it's difficult design team use BIM authoring software from their early design stages. It's because there are so many constraints for design communication if you directly use building information authoring software. So the designers prefer to use CAD-based software. And this issue can be solved with internal company training that designers as well as BIM authoring software users or BIM team has to coordinate each other by training the design software or BIM software in each department at the same time. So the designers in the future should also know about BIM software, especially the major BIM authoring tool in the organization if they use such as Autodesk Revit or ArchiCAD, Allplan and other softwares, then it's important that they also know basics of BIM software so that when they work with the design, they can think about the the future phases, what they can contribute to the BIM department. The BIM department also shouldn't just think about documentation in planning tools such as Revit. It's also good to know the data interpolation, how they can bring the data in BIM application from design tools, so that the workflow or the communication between design team and BIM team can be much more efficient. Today I'm going to introduce particularly the connection using Rhino and Grasshopper especially the Rhino has very powerful visual programming tool called Grasshopper. And this Grasshopper can be linked to a lot of different BIM authoring software. But I'm going to highlight a couple of examples using Autodesk Revit with Grasshopper. And also some examples I would like to introduce using dynamoBIM from the Revit's visual programming part. Okay, let's get started. The data exchange from Rhino and Grasshopper to Revit. Previously, there are many applications available. Here I'm sharing one slide. In the past, we used like Riverbird or Chameleon, and also there are multiple solutions using Revit API. Nathan Miller was introduced many different tools in the past, and also Hummingbird, IFC Geometry Gym by John Massin. There are also the previously Rhino was inside of Dynamo was available for such a data exchange. And the company Case also introduced OpenNerves to Revit. That plugin used to exist, and Gravit and Constru also is kind of interesting tool that Grasshopper visual programming script can be transferred to cloud system, and that the structural element could be imported in Revit. Anyhow, these tools that last couple of years, many design firm or the planning office used it. However, currently McNeil Associate also offers the Rhino Inside for Revit, which Rhino can be operated inside of Revit so that you can access to both Revit API and Rhino and Grasshopper API documentation within one tool, which is very interesting. And some of the case people or colleagues has the mindset that visual programming is not for them or is difficult to follow that logics. Then there are some other tools such as Conveyor by Proving Ground and Beam, which can help the designers and also the computational designers could prepare the script for their design team, and they can just click on the button like solution, click and button solution to transfer all the data to Revit, for instance. And yeah, so today I'm going to look at some of the old examples that I prepared in the past or practiced during the university time, and I hope this brings you some good idea for your workflow. So here is my university master thesis that I used many different design script using Grasshopper that allows me to scheme an early stage of design using parametric design solution, and that multiple geometrical data and also parametric attribute can be transferred to BIM authoring software such as Autodesk Revit. And I think it's nice to present this project. For instance, if you look at the design development from here, I can show that perhaps this is the gallery. The benefit of using parametric design solution or generative design is that we can using input data such as like different parameters that can form and regenerate many design proposal, and we can choose different options by changing the parameters. And that idea is perfect as an architect or designers to use visual programming such as Grasshopper. However, this complex geometrical data to transfer uh, BIM authoring software is kind of challenge, and in fact, many case the presentation is prepared only in CAD software such as Rhino or 3ds Max than actual BIM software. And in this project, I was struggling a lot. Of course, back then there was no direct link between Rhino and Revit. So I had to use Grasshopper definition and streaming the data as CSV file to generate topography in Revit. And also in Revit, there are a bit of manual geometrical operation I had to go through. But currently, the Rhino Inside for Revit has a lot of positive potential that we can regenerate Revit native geometry from Grasshopper definition. And I must say this project is quite complex um, to model in Revit. And during this workshop, I'm going to present, of course, different work examples. But at the end of the webinar, I'm going to also show Ryan the live model of this particular project. All right, let's go and take a look at some drawing. Of course, the project using design tool brings us lots of creativity. But as you can see from this plan drawing, it is very challenging. It's difficult to document accurate um, plans only in design software. Of course, you can do it, but it takes a lot of effort. And if you look at this complex, of course, it is um done in Revit, but a lot of um, geometry that couldn't be possible without using design tool such as Rhino. And as you can see, if I go to the section, let's say master section A and A, the complexity that the topography and the landscape of the project is integrated with architecture. And when you look at this long cross section, it is definitely um, has huge potential linking design model to BIM authoring software so that this kind of drawing is accurately generated and we can present in much better manner. And if I look at also a little bit more detailed section, the section is based on 3D elements, of course, and just we increase the level of detail of this section and just a few detail lines and annotations or 2D element, but the rest of the drawing was fully generated from 3D geometry, which is really powerful um, using BIM authoring software. But without using visual programming tool was very difficult to generate all these drawings. In many cases, there is misunderstanding that the parametric design tool is only focused on geometrical generation for form finding, but actually the parametric design tool is even more strong when it comes to analysis process. In this case, I was analyzing the site context, especially for the sloped area using dynamoBIM, and we could find out the slope angles and as well as um, the slope. If that slope is more rapid and dramatically big drop, then it highlights in darker red color in this case to show and visualize the data. So, and here I'm going to introduce another example that the the large BIM data, especially for the site context, when there it can contain lots of the site data such as neighborhood information, and you can also link your BIM model data to GIS or the particular Google map, or like in this case was using different 3D um, panoramic viewport of the site context. And you can also indicate that the neighborhood characteristic, and you can also show different level of detail when you manipulate the different attribute, so that the design model can even be more accurately analyzed. And in this case, the site has very specific environment that has huge tide, which goes maximum of 20-meter height. And you can see the surface area of the different land, how it uses, and this kind of data analysis can be very easily done in building information modeling software. But the whole collecting all this data, um, of course, we could manually do it, but that the data was the data model was modeled in Grasshopper, and that data was transferred through the Excel sheet, and in Dynamo we linked the information and providing that site context and neighborhood characteristic using this data transfer in dynamoBIM. And the specific family indicate that with the color code, the different site condition of the neighborhood. And as you can see, yeah, it was very handy to parametrically um, show the diagram of site condition, and all this geometry is contain not only graphical information but also the non-graphical information, so that all this metadata, and we can see here how many private area and where the public and semi-public area can be analyzed for the entire island. And this data can also be streamed to dashboard, such as back then the link of this data, for instance, the address of the context, and also the material of roof finish, the shape of the roof. So we could analyze all these the building stories and the type of buildings for entire context model was exported to Power BI, and the Power BI dashboard can be shared uh, to the planning team so that they can mining the metadata or big data of the BIM model and filter that information for design development process. Another example project here is done by the group of students at University of Applied Arts in Vienna. That we got the public fund that um, the school aimed to build a Kinetic pavilion, and of course the Kinetic pavilion in real site on site, and it has to be temporary exhibit at least for months, so that um, for the student level during this one short semester to achieve this Kinetic pavilion wasn't easy. However, the group of students um, had a really good parametric design analysis solution to analyze structure as well as the old kind of physics and kinetic choreography to realize the project. And I'm very proud to present this particular project um, during this webinar. And the credit is, as you can see, the studio was called Zahadid Studio, and the I was a member of the studio as a student back in 2014 and 15, and yeah, I'm gonna present a couple of workflow. So it was real project, and to get the permission from the city council, we have to comply certain constraints, and to achieve good visual sightline for the visitors, I used the dynamoBIM to find out the optimum position of the pavilion so that we can visually um, uh, see that kinetic pavilion from the distance. And the Dynamo script is intersecting the physical constraint with a um, and it generates the section at the intersection between human sightline and the physical barrier, and we could find out the best optimized position and the metric constraint of the pavilion, so that in the planning process, this analysis could help us to um, yeah, predict and predict the passenger and visitors movement, and also the um, potential um, um, sight line where it can be blocked by the barrier. This was interesting because the design model was directly communicate and integrate to BIM authoring software, and that all the data can be directly used in BIM software. So, and also the site context, um, there was a canal right below and front of the pavilion, and this kind of analysis using the parametric design tool was very useful and helpful to um, predict that kinetic structure and how it can be visible on different viewpoint. And this was very important because spending lots of effort and the public fund, and we didn't want to make that structure hidden by surrounding context. So this analysis was very useful. And eventually the design data was very well documented in BIM authoring software. So you can see here all the benefit of using parametric design tool, especially here the choreography of the kinetic structure, where it shows different perspective and front and top view, how the movement going to be realized in your project. We also have to take into account of the wind direction and the actual structural property for this kinetic structure, because it's consistently moving, and the wind on that construction site was always kind of strong wind in this micro area, so that for as a student, as an architectural student, to predict that structural failure during this area, especially for the kinetic structure, was quite challenging to understand it. And the Grasshopper visual programming, such as Canvas 3D, was very handy as an architectural student to predict where can be weak part of the members, so that we could discuss with the structural engineer directly, and that engineers can focus on that joint area or the weak part of the members to optimize the structural property. So this is also very useful when you work with visual programming. Without visual programming, I think to update this kinetic structure um, and especially to know about all this kind of site context uh, property, that we could analyze the structural part wasn't really possible. I cannot really imagine doing it everything manually. So it was huge advantage of using visual programming. And also the surface tension that we could predict when wind is blowing, then the we could predict, depends on the material property, how the surface can be flew based on the wind direction, and based on that we could also imagine the tension and the material of the this surface material. We could specify it more carefully using the analysis here. In this case, we use Grasshopper plugin called Kangaroo, and yeah, that process was very useful and helped a lot for us to choose the proper material. And of course, at the end, the full documentation was much easier when we link the design proposal directly to building information modeling software. At that time, the geometry was basically imported in Revit from SAT file format. So back then the Rhino input wasn't available in Rhino native file import wasn't available in Autodesk Revit. So the baked Grasshopper geometry was linked with SAT file format, and still we could document it accurate in the documentation process. Yeah, and the eventually that helps us to determine for choose of material and also the yeah, estimating and scheduling the full element, fabricated element, and that helps us definitely for the major design decision. Yeah, and also this sort of the kinetic structure was difficult to position, for instance, the motor as because the BIM model, when you think about the fabrication on in the factory, that more careful the test should have been occurred and proceed so that we can somehow the document this angle of motor movements to comply and produce the parts. And this kind of challenge was, of course, much easier in BIM authoring software. Let's look at some other example. For instance, here we are optimizing the cross sections of the cantilever structure, and the Grasshopper's Caramba 3D and Galapagos plugin was used to analyze the structure and choose the optimized cross section of the here the structural elements, and um, the this kind of analysis is real power of parametric tool or design using visual programming. And that I must say that this kind of analysis is also including all kind of data, structural data. So we can say that this is also directly affect for the building information modeling process later. There is also early design stage how we could optimize or using the data-driven design method. The we can give the input data such as the apartment percentage, square meter per percentage, and the number of parking for each apartment type, and we providing this different apartment layout with certain metric, and there we can see the circulation constraints, and it generates the parametric design tool generates the different design option that you can select, and the compare the design options in generative designs way. In this case, the Grasshopper was used with a Wallace solution that generates all kind of design output, and this design decision making was much easier by looking at the dashboard of the optimization. So eventually you can exploring all these different design layout, and the yeah, you can also calculate the kind of early price cost estimation result. So until now, we had looked at a couple of examples of parametric design tools such as Grasshopper, definition, defining analytical models or analysis of structure, and also the schematic design process helping the site context analysis, and also these kind of the early design stage or the analysis result is huge impact on the building design, building information modeling process. Now I'm going to show the most current direct connection using Rhino inside Revit, and um, in this particular workflow is very interesting because the Grasshopper definition is directly linking into Revit documentation. So let's take a look. Here I brought the tower design. In this case, there is a complex slab profile happens in this common space, and the slab design is continuous change from certain range of floors, and the rest of floors has typical structure. Um, and the diagonal columns and the wall and slabs, as you can see, these are all native Revit elements from the design script. And you can not only create this system family in Revit through Grasshopper, you can also generate all the datum such as level and grid. And here is the Grasshopper design script that, as you can see, we can stand. So let me open first of all the actual design script that generates the geometry. Um, the script, when you work with visual programming, there is no certain debugging tool, so it's important to use good color code to indicate what current or this components does. And for instance, here I'm highlighting the design data input and output with red color. That's the file that I can save the streaming file outside of this Grasshopper definition, so that we can synchronize for the structural analysis or transferring data into Revit using Rhino.Inside.Revit components. We can avoid very heavy performance from long visual programming script. And the using color code is important because you can indicate which component the team or colleagues can modify it or they shouldn't touch. So using the kind of color code legend, for instance, here we have a design option with pink color or control parameter. And then I jump into the design option, and we can set different design option to display the design. And without this kind of legend or indication in your visual programming, yeah, it is very difficult to debug someone who didn't work before, going through all these components. That's downside of visual programming. But if you structure the project template or the project canvas in Grasshopper with a certain annotation and indication, then that helps a lot to modify or continue to work on the script for other colleagues. And here, for example, the starting point of this curved slab, we can manipulate it, and the data which we can synchronize. Right now it's locked, but I can enable the data output component so that all the data we regenerate from the Grasshopper script can be synchronized for the future phase projects. For example, we can use it with some third-party plugin I'm going to show you later with a Sophistic. Can read this design script directly with a Sophistic for Grasshopper plugin, and so that we can calculate structural analysis. Okay, and yeah, if something need to be just for the information dashboard out of this graph mapper, you can also highlight it in yellow um, group so that you can see that kind of information is displayed. And also here, if something to deal with the graphics, I highlighted in purple color. And now I just switched to the structural calculation script where we can define that Grasshopper data output file, and it will bring basically all the defined geometry into this new script. And we can only focus on, like, for example, structural engineers only can focus on their structural analysis task instead of going through all the complex script from previous steps. So this is another way um, that you can collaborate with different disciplines using visual programming. So it's very important to structure your script, when you should deliver and how can it be organized. Without this kind of little organization work, yeah, the visual programming can be very difficult to understand from other users. Now the structural analysis was carried on using another third-party program such as Sophistic, and everything is parametrically adjusted. And the real benefit you'll see later. This initial concept design can be always, changed, but the structural engineer can adopt whole structure with a single button of click once the script is prepared, and then that proceed all the previous calculation steps again without any further input or efforts. So this is really great use case between architects and the structural engineers to collaborate through visual programming. And yeah, the structure you can also measure the behavior. Okay, where is the weak? So you can reflect on that huge deformation on the slab by enhancing the structure in Grasshopper definition. Now I'm going to show you how we can apply all these Grasshopper geometry into Revit. And in this prepared example, back then I used Rhino Inside for Revit before 1.0. So there was no element tracking method introduced back then, but now you don't have to manually delete all these generated elements. You can basically set the tracking options in your Rhino Inside Revit components, and any kind of design adoptions will be automatically updated. But back then I had to delete the generated elements to regenerate. Now I'm clicking on here Rhino Inside. Rhino Inside is installed in Revit environment. So the actually Rhino is just popping up within the Revit, and they share the same memory. So which means you can actually access to Rhino API and also Revit API at the same time within one application. That makes very strong because the Rhino has huge and very good, well documented API environment, and you can customize your tool even stronger with for Revit workflow with Rhino inside. So when you click on the open viewport within Revit, you can see Grasshopper and Rhino viewport is opening. And yeah, now I'm going to adjust the view a bit because we need a three kind of viewport to see. And I always recommend to disable the server before you start the Rhino Inside script, and also turn off the preview in Revit because the performance can be very slow. Um, if you're dealing with complex geometry. And now let's open the script. I'm going to leave it the servers as disabled, and here's the script that I can generate Revit native elements. Now we use same technique, going to use the data input to bring the design scripted geometry, and this geometry going to be converted as a converted converted as a Revit native families. So we'll create foundation, slab, columns, wall, and insert some opening families in this case. I'm here going to make sure to disable all these components so I can show step by step each element. Let's go ahead to create, first of all, Revit datum such as level. So I'm going to recompute the script, and then yeah, because it's locked, the server is disabled, we can still execute the script step by step by clicking on the recompute method. So this is another like a kind of workaround that you can debug or test your script certain area by disabling the server. And now, if I go to the Revit view, and here you can also recompute from Revit viewport, or in Grasshopper you can click to recompute. And now you can see we generated the Revit levels according to the naming convention. So isn't it nice that one click generate all these levels? This kind of work you can also do in dynamoBIM. So the benefit of using two different visual programming, you can bring the benefit or advantage of Dynamo and also Grasshopper, advantage of Grasshopper. Now I'm generating also the floor plans where the complex slabs are applied. And let's take a look at the slab when you generate the native Revit foundation and slabs, then we can get the plan view immediately in Revit. So this is another benefit that the design model is linked to your BIM model. So now let me execute, and as you can see, the foundation slab is just generated automatically. Yeah, I'll make the maximize the levels in as a to see full scope of view, and now I'm going to enable the slabs. So let's click on enable the floor slabs in Rhino Inside, and each slab will contain opening family. So the next group of script will define the location of the insert family, opening family, and also the size parameter. We can control it. So as you can see, the all the slabs are just generated within a second. The performance is great, and yeah, the geometry also looks really great in this Revit viewport. Now we just organize the tree structure, the Grasshopper tree structure, and find out the center point of the slab, and we can insert openings, and also the spatial family is inserted, and that parameter also adjusted through the Rhino Inside script. So when I now recompute, you can see all the openings are going to be inserted. Yeah, it's beautiful. So we can see the shaft openings are applied, and in the plan you can see the symbol directly. So you can imagine how quickly we can bring the design model into BIM authoring software using this kind of visual programming solution. And it is not only applied to Revit. If you use Tekra or ArchiCAD, they all have this Grasshopper and Rhino connection. And later, I'm also going to summarize all the possibility using Grasshopper with a different software platform. So let's stay tuned and let's go ahead now. I'm going to create the load-bearing walls. So I'm going to enable and recompute, and the Rhino Inside generates all the walls, um, which split floor-to-floor levels, and yeah, it's a Revit native elements, which is really great. And now I'm going to also generate all the columns. So probably I'll start with the main column. So just enable only this bit of script and recompute the script. Then Revit bring all the columns. We generate quite a lot of columns, so it takes a little bit of time, but with simple one click, the correct column height and location of the columns are applied at the position. Beautiful. That's really power of visual programming. Automate this full workflow. Um, that's really great. And now I'm going to generate the subcolumns that is slightly offset from the major columns. And as you can see, the subcolumns are also generated. And we can also finally generate the slanted column. Just enable the script and recompute, and all the slanted column also applied at the correct position. So the structural tower design just finished, and you can fully document now typical Revit workflow or dynamoBIM to automate the documentation process. This is one of the example I want to show in terms of building design. Let's probably change a little bit of geometrical input, and yeah, there are some warnings showing that some of the element doesn't have correct maybe parameter name, but for at this stage we can just ignore these warnings. What I'll do, I'm going to also review the model shortly to see if everything looks correct or not. And in the plan view, let's draw section, and all the sections are beautifully applied. Yeah, you can see openings are there, words drawn correctly. At the moment, as you can see, the top constraint is unconnected because we didn't give the parameter and of the base offset and top offset. But this is just a matter of set the correct value in the Rhino Inside component. And if you look at now here, I'm going to open Grasshopper again and disable the whole Rhino Inside component because it takes some time when I change the design script, and I don't want to wait for small changes and waiting for all the updates. So just turn it off, and yeah, let's select the old element except the levels, because I'm not gonna regenerate the level, but all the element. Yeah, as I said in back then, this video when I record, Rhino Inside was not ready for element tracking options, but now you don't have to manually delete and regenerate the element. You can track the element, and Rhino Inside automatically updates or replace the element if it's necessary. Okay, so we have the levels again, and in Grasshopper and design script, back to the design script. And let's take a look. I'm going to reparameterize or change the attribute of design. So maybe these complex slabs, we can move it up, and accordingly the whole slabs updates, the columns are linked accordingly, and we have new floor design here, and whole structural design is new design is applied. And from the data output, I just enable the component, and once you enable, all the design change is going to be synchronized to the output data. Just wait a bit because the huge data is applied. Usually the performance is very good, but sometimes when I share the screen, it takes a little bit of time. Now, when you come back to the structural analysis script, as you can see, the new applied geometry is already loaded into the script, and the third-party plugins, the data is already fluid, so which means we can analyze this new structure in sophistic. So let's take a look at the new updates. When I just simply update the design input, which is basically streaming the data output from the Grasshopper component. So I'm going to recalculate this new stream data in structural engineering software. So just calculate. It's a big tower project, and it takes a little time to calculate the geometry. Once the linear analysis part is done, and you can take a look in the system visualization, and yeah, we got the new tower which has correct material input and also the cross-section information, and the whole new structural analysis is applied. So structural engineer doesn't have to put any um, redundancy, or I mean the work that if the whole design change from the previous steps, they can only focus on pure structural engineering rather than regenerate this analytical model on their own. So that already helps a lot of effort between architects and structural engineer to communicate. So once the workflow is set, now let's imagine that confirmed analysis model need to be documented in BIM platform. So we use Rhino.Inside.Revit, and let me compute to bring the updated geometry from design script. So we have here in Rhino.Inside script, now the design model is updated. And now I'm going to apply the entire geometry process. So just enable it, and I'm going to recompute at once all the elements in Revit. So coming to 3D viewport, and when you recompute, let's take a look. It takes a little bit of time, but you can just wait or go for coffee while it's regenerate all the elements. But the performance, I must say, is really great. And this, imagine you have to adopt all the changes manually without this scripting workflow. I guess it will take so much time and effort to always regenerate the whole geometry. So the model looks good in here, and everything is updated. Yeah, and according to the BIM model, your data attribute is updated. If I generate some new floor plans, and as you can see, the floor plan is also automatically updated. And when I go to the section view, you have complete new section geometry generated. There is a small mistake in the data structure to offset one of the floor, um, and yeah, it just you can just work on short Grasshopper definition, and you can change that error. And apart from that, the model looks really great. Yeah, all the changes applied correctly, and we are happy to continue to the later phase to design facade elements. And of course, we can do whole process in different Rhino and Grasshopper script to enhance this building project. And your task, your daily repeating task can be shortened using this visual programming. And I believe this is really a powerful tool and saving up a lot of time for the collaboration and communication between different disciplines. After this example, I'm going to show one bridge example that you could use pretty much same technique, but the infrastructure project generally more complex than the high-rise building project. So you can see the real benefit of using visual programming. So as I mentioned it earlier here, we have a bridge design and the whole geometry from the Grasshopper definition transferred to the Revit project file. Um, the I'm not the structural engineer, so as you can see, the bridge itself is not the 100% realistic project. Especially the diaphragm in the middle, I just put the position in every interval, and also the bearings and bearing plate. I was looking at the just image file and just construct special Revit family out of the image file. So I'm sure the um, the detail when it comes to the detail that it's not really a realistic project, but nevertheless you can imagine the workflow how I can apply the visual programming scripted bridge geometry transfer to the BIM authoring software. So we're using the same technique using data input and output. So the from the design script of all geometric model of the bridge was generated using sophisticated bridge component in Grasshopper, and it's fully parametric bridge geometry that we can bring the data using data input components, and you can take a look. Yeah, the segments and also the shear keys and etc. And all this data from the design script, as you can see, the parametric axis definition or the so basically the bridge axis was parametrically already defined by sophisticated plugin, and this is great, especially when you have to deal with the variable cross section of the superstructure. It's very challenging to generate this geometry manually, but I understand many bridge engineers using 2D documentation tools such as AutoCAD and model in AutoCAD for one segment, and then just repeat pretty much the manual modeling process, or some of the bridge engineers using specialized software like Sophistic for bridge engineering tool in Revit that helps the bridge engineers to automate the to generate bridge model. But I think the visual programming such as dynamoBIM or Grasshopper is perfect tool because you can really set the parametric cross section of the bridge, and then this all design change can be simply applied and update um, based on the your design script, and the full whole geometry applies um, to the final result, which is really strong. I found it's really strong. So I'm just gonna show you the this Rhino Inside part once more. So the all the design elements are generated already in Grasshopper, and yeah, Revit already implemented some of the bridge categories such as pier or abutment and bridge beam. So we can convert all these parts to native Revit category, so you can really get the proper sections and plans and document your whole bridge documentation in Revit. One thing good about Revit is that you can, um, share this file pretty much to all kind of collaborators, and many collaborators requires these days to use Revit file. So Rhino Inside in this case is great help, and you can also set the level information, special parameter automatically we can generate. And now I'm just going to recompute to produce all the geometry. With one click, now you can see the power of, again, visual programming integrated with BIM software. In this showcase, I'm still showing between Revit and Grasshopper connections because it's one of the popular connection in our industry. But basically, you can do all this workflow. There are many applications such as ArchiCAD or Tekra has live connection with the Grasshopper. If you're thinking about CATIA or the OpenBuilding, the Bentley products, they have their own visual scripting tool within the BIM authoring software. So yeah, the most of software developing companies or vendors now also implemented this programming workflow. Yeah, you can see now the tendons and tendon space cap, they are all generated in Revit. And I know that the right now peers every instance are applied from Grasshopper definition, and just because of the transfer time, all the segments are modeled as one um, um, generic model. But if you graft the data structure in Grasshopper, then every single segment will be applied to as a one section. Right, so it's just for the demonstration. You can see in terms of shared key of the connection part. Of course, you can make a very detailed model, but I just decide to use adaptive component and populate the location of share key so that you can annotate or tag in Revit. So these 4-point adaptive components will be applied at the position of all these share key, top and bottom and webs. So I just define the correct components. And when I define that, and now if I recompute, then you can see we have all these families are loaded in the project. So I'll set something here, and now if I enable the next script here and recompute to populate Revit adaptive components, it will indicate the share key locations. Let's take a look. So now the point of share keys are were sorted in Grasshopper. Now I'm going to recompute the process in Revit, and you can see after a while all the share keys are applied at the correct position that you can document in plan view or section view in Revit.
Yeah, the adaptive components are always takes a little bit of time to load it, but I think it's very intelligent. One of the most intelligent geometrical tool or family, let's say, in Revit that you could do. You could achieve many different complex geometry in Revit using adaptive component. After waiting for a few seconds, and as you can see now, we have all these shear key positions placed on the every segment, and you can see top, bottom side of shear keys there, or you can find it. Okay, so yeah, diaphragms and every shear keys are there, and as you can see, I'm going to also apply another load over family, which we just built it up as a Revit family. So if I go now, insert bearings, we will find every point of the bearing location from Grasshopper script. And at this point, we can insert the specific Revit family. So I'm going to um, open Rhino to verify once more the bearing position. And as you can see, those points, they are coordinates for the bottom part of the surface of the bearing support. So I'm going to enable the last components and then specify the family, and we can add the components at the location of points. So now I'm going to recompute the script. Let's take a look. Yeah, before I execute, I just want to make sure that yeah, everything is there, and yeah, so now I think the whole geometry is correctly built it up in Grasshopper. So now I'm going to recompute, and as you can see, the wrong family was selected from the script. So let me undo the process, and we have to define correct family here. So I want to put the bearing family. It should be listed in somewhere. Let me check. Yeah, if I insert now, now it's loaded into Revit system, and let me execute the script so that I can find the family from the drop-down list. So we have here bearing type that I can define, and I'll execute one more time to place the bearing. The bearing family position, the orientation is not it's difficult to define through the Grasshopper. So some point these elements I have to manually position in within the Revit. So you could just rotate them from the plan view. It's not so many, and it's very identical to follow that orientation. So once this process is done, your bridge is already ready to document in Revit. So now I'm just going to repeat the process a little bit. So just rotate the bearing position to the correct orientation. And that's yeah, probably you can imagine to orient that vector direction of loaded family automatically, but I was a little bit lazy to script everything in Grasshopper. But yeah, if you can improve it, I mean, you can also just automate this process. Probably it's better if you have more than 20 of them, so you don't have to manually go through all this element. Or we could also set in Revit family a certain rotation angle. I could have measured the angle of rotation and then put that attribute in family, and the family wrote the parameter automatically, and it just have rotation angle value within the Revit uh, parameter. Now I'm going to just save this file. And you can also define, now it's everything is defined in Revit. You can also see different material property. Materials are also generated from Grasshopper, so it follows pretty much same color code, design code from the Rhino and Grasshopper drawing. But yeah, we can go through now, take a look at the section of this bridge model. And one nice thing is that the complex geometry now can be reinforced in Revit using reinforcement tool in Revit. I think Revit improved quite a lot last couple of years in terms of reinforcement design. And yeah, this kind of visualization can be done in 3D. Yeah, and you can also annotate just all the geometry. Just now it's native Revit elements, so basically you can put any annotations or taggings and define, and eventually you can also export the element as an IFC model. All right, that's pretty much it for the bridge part. So the bridge part is done. Now wrap it up. The webinar, I'm going to show the master thesis project that complete the same workflow except Rhino.Inside.Revit. I used a lot of Grasshopper and the Dynamo connection back then with Rhino Inside package in Dynamo, bring the Grasshopper data. Yeah, so but I can imagine now the design model from Rhino can be very easily documented in project in Revit. Let me just share the Rhino model as well. So you can see here the Rhino model, the design model is fully modeled in Rhino and Grasshopper. The It is quite heavy in within the Rhino model, but let me hide the surface edges. The this complex, all this complex, and also the fine detail was transferred to Revit, and that was very helpful for documenting the final project. So let's come back to the Revit screen. You can see right now the everything is native Revit elements and also has the certain level of detail that complies to my preference. And when you look at the plans, Revit is really powerful to document this kind of drawing. And everything is 3D. It's based on 3D elements, so there's no 2D drawing except the annotation. Let me show you some maybe some of the plan that is also documented in Revit. And I have a good introduction in my YouTube channel in the whole presentation of the project and also the workflow um, um, for this particular project. So if you're interested in, you can also search on Point On Studio on YouTube, and you can find out the shared video. Yeah, so it was quite challenge to document that, and yeah, but it works quite good. And if you look at the section you can see the model is fully documented in Revit. You can see. You can go and take a look, find details. And if you look at the actual element here, they are all 3D object of Revit model. We just changed the level of detail in the detail drawing. Some annotations are 2D, but apart from that, everything is 3D element that you can easily. So these are the 2D elements that is grouped, but basically some detail components and some detail part. But apart from that, they're all 3D elements that generated from the design model that you can really take benefit of this workflow. And also, yeah, the benefit, it's slow because the model is very big, but Revit has very good documentation ability. So I decided to bring the geometry from Rhino to Revit. And you can see, for instance, I want to make, though everyone pretty much knows the benefit of Revit, but if you click on the section box, we can just look at the 3D model that cuts the geometry, and immediately you can see what is going on there in real time. Okay, so I will wrap up. So that's the whole story behind, and I was convinced using visual programming for the whole workflow. And I would like to summarize the my presentation with one grasshopper diagram, and that maybe makes you to rethink or organize yourself what workflow could be the best option for your daily practice. Okay, for the last 10 minutes of the webinar, I would like to summarize the whole presentation in simple diagram here. The most common visual programming in building industry at the moment is Rhino and the Grasshopper for Rhino. On backend, you can also use Visual Basics or C#, F#, even JavaScript or Python, Iron Python, that you can natively use in both Rhino and Grasshopper to come up with some plugin development. And if you look at current, and I'm not even including a lot, like whole the software package of our industry, but when you look at the integration with this visual programming, can be really broadly integrate with all kind of workflow and data that can be shared with all disciplines. And of course, the data can be even streamed simply to Microsoft applications, and that kind of Excel can be the data interpolation tool as well between the platform. And many third-party companies, they are also developing the kind of the data interpolation options. But when you look at the 2D graphics, we use Adobe products or many new 2D graphical editing tools that can be linked from the Grasshopper definition. As far as the visualization programs and also the game engine has live connection with Rhino and this gaming engine. 3D CAD and design, many well-known software such as 3ds Max, Maya, Blender can be linked directly from Rhino and Grasshopper. There is no Rhino inside for 3ds Max and Maya yet, but you can also develop yourself if it's necessary. And also the digital fabrication tools such as the SurfCam or KUKA, RhinoCam that can be simulate the fabrication stages using Grasshopper plugin. And all these Inventor, SolidWorks, they have ability to import the Rhino data output. So that's also very optimistic. And in terms of BIM coordination, you can think about Navisworks or Solibri or BIM Vision, DDS-CAD, Tekra, Connector, and or BIM Collapse application that you can apply the BIM coordination. And the CAD or BIM authoring software these days pretty much have good right connection with the visual programming. For example, BricsCAD has also Rhino Inside or the functionality on it. Revit, ArchiCAD, they all have good connection with Rhino. Things like CATIA or the Bentley software doesn't have direct connection with Grasshopper, but they can import the 3DM file, and also they have their own visual programming tools, so that's very powerful within their tool. Many structural analysis tool is also has Grasshopper plugins that you can use, and also the project management tool such as you know Drupus or Economus. They are linked from Navisworks data or IFC model, but Rhino can also be opened in Navisworks and it can be exported as an IFC model. There are some third-party companies such as CodeMill developing the IFC exporter for Navisworks. So you can also bring all the data in Navisworks and map it as IFC model to export it. NeoTwin company developing Parametric that helps the project management and asset management. So these kind of hidden domain which wasn't really digitalized in the past now has ability to bring all the data from building model in their system. And which goes without saying that the analysis tools they have all now integration with good CAD file or BIM model data set. Some of them, for example, the Ladybugs, they have even Grasshopper integration, so you can enjoy the whole ecosystem of the visual programming, especially the Grasshopper world. And these data never ends, and you can also use your CAD or BIM model, and that can be displayed in cloud-based systems. So nowadays we are talking about the Shape Drive or Sketchfab. Some of them you can use it as a free version, and yeah, your BIM model or your scripted model can be displayed on cloud system. And Studio 3DX particularly has a plugin for Grasshopper, so the Grasshopper model can be directly visualized in cloud system. Yeah, there are Dialux and Autodesk BIM 360. All these sort of tools are very developed, and some of the open source like IFC.js or Speckle, you have a direct integration with Grasshopper to visualize the your Grasshopper BIM model in cloud system. And you can do also further data visualization using Power BI. Autodesk BIM 360 currently announced since May that your BIM data can be extracted in CSV format that can be import in Power BI, so you can visualize your BIM model in, or you can use Trello or Contact, which our company developed. to visualize field data from the construction site using sensors, and that can integrate with BIM model, and you can visualize your data. All right, so as you can see, the potential and uh, the amount of data we share can be easily streamed back and forth using Rhino and Grasshopper, and I think yeah, that's brings us or bridge the gap between different disciplines and the helping us to save up a lot of time. I'm not here talking about yet the Omniverse. There's Omniverse by NVIDIA that all this application can be even bidirectionally at the same time in live with live connection of Omniverse tool that you can also develop third-party connector between Omniverse and all these kind of tools. So the future is right, and we just need to think about what match to your business the best, and to how we can efficiently collaborate using the uh, visual programming. Especially many design disciplines, as I said at the beginning, that very detached for the BIM workflow. But in the future, when everybody is familiar with visual scripting or text scripting, that bridge the gap between design discipline to the planning team, or the planning team also improve their design ability or the collaboration ability using visual programming. That helps a lot the miscommunication between the disciplines and improve the work process and documentation process. And more importantly, your workflow going to be always developed, and you'll have much more fun while you're working. Thank you very much for the webinar.